Alright, so today's topic is dealing with the AP idea of if a function is increasing or decreasing, and if so, over what intervals. Now visually, you can see that this graph is increasing from here to here, decreasing, increasing, decreasing, decreasing. But using calculus, how do we know? Well, think back. The whole purpose of the first derivative is to tell us the slope of the original function at some point x. So the derivative of this function would tell me that we're increasing here, we're decreasing there, we're increasing there, we're decreasing, we're decreasing. And these changes from increasing and decreasing are bounded by the points at which we go to a slope of 0, where f prime equals 0, or the points at which f prime is undefined. So let's take an example. Given f of x equals x cubed minus 3 half x squared, first find those critical numbers. Just like yesterday. So differentiate. If I differentiate that function, I get f of x equals to 3x squared minus 3x. Step B says to factor the numerator and the denominator. Factoring out what I can, I get 3x undistributed out, leaving behind x minus 1. Step C says to set that answer you just got equal to 0 and find the zeros. Well, 3 times what is 0? 0. And what minus 1 would be 0? 1. So those are my two critical values. There are no asymptotes because there is no x in the denominator of our derivative. So once I have those critical values, I need to, step 2, pick values out of the intervals that are left. Now let's think about this. I'm interested in the numbers 0 and 1. There is no interval for the original parent function, so we're going to evaluate it from negative infinity to positive infinity. Okay? And I want to pick values out of each of these intervals, out of this interval, and this interval. The reason I'm doing this is because f prime of x equals to 0, the slope is 0 at this point and that point, but f prime will be equal to a number value, a slope value, at some number in these intervals. So I'll give you an example. If I pick, come on, negative 1, for instance, and evaluate this function, f of x, at negative 1, I get f of negative 1 equals to 6. Well, guess what? This function is increasing from negative infinity to 6. What I know? That's a positive slope. That's a positive 6. It's increasing. What about this interval right here? Pick a value between 0 and 1. How about 0.5, 1 half? F of 1 half. Plug a 1 half in and do your math. And you get a slope of negative 3/4. Our parent function is decreasing from 0, 2, 1. Okay? And then finally, something bigger than 1. How about 2? F of 2 equals 2, positive 6. Positive slope, we are increasing from 1 to positive infinity. And that's it. Homework is out there on the website. You may want to start looking at it. We'll obviously work on it in class tomorrow.